Welcome to the Cowtown ATU Radio Club's Buildathon program, and this is to introduce to our members project number 3. When we started the program at the beginning of the year, we set out to deliver 3 projects. The first was to build an end-fed half-wave antenna. The second was the ADX, a digital transceiver. And now for the third project in the series, a QRP antenna tuning unit. Now here's a close look at it. You can see it's a fairly attractive unit, housed in an ABS housing and well presented. So how does it work? What's the project about? Let's take a look. To demonstrate the use of an ATU, I've connected a non-resonant antenna through my MFJ 969 to highlight how an ATU is able to tune that antenna and illustrate the impact using the analog SWR meter. Because we're using QRP, that particular meter doesn't show the power levels particularly well, so I've connected it to the barber watt to get a more accurate reading, and the power source that I'm using, or the RF source that I'm using for this, is the ADX, the kit that we built in project number 2. For this demonstration, I have my 20 and 15 meter dipole feeding in to the large roller inductor antenna matching unit, which has a cross needle SWR meter. Now, whilst this unit can measure up to 300 watts, it's not particularly accurate in terms of its power readings down at QRP power. So I've got the barber watt sitting here, which will give us a much more accurate power out reading, as well as a digital SWR reading, and it connects through to the ADX that's sitting over here. Now, the switch or the area of interest is going to be this particular band selector here. You can see at the moment I've got it on bypass. This switch enables me to connect either 1 or 2 antennas, a long wire antenna, or into the dummy load. In this case, I'm on bypass going in through coax number 2, which effectively means the ATU is not being used. It's connected straight through to the antenna. So when I power down, or when I power up, you can see here that the SWR, which is reflected by the point of intersection of these 2 needles over here, is absolutely in an unusual range. And if you look down here, it's about 8 to 1, and I'm only getting about 1.5 watts out on 40 meters. So not clearly a good situation. Now, I've actually tuned the antenna. I just switched it across to the ATU, and you can see now, having tuned it, I now have an SWR of 1.14 to 1. You can see the cross intersection here involves virtually no movement at all of the reflected power. So we've got pretty much close to a perfect match, and that makes it usable on 40 meters. Now, not necessarily the most efficient 40 meter antenna, but it certainly will enable me to use the dipole in the limited space that I have for operation on 40 meters. Now, the way you tune an ATU to match it to a particular antenna is you first select the inductance that you need, and then you adjust the 2 capacitance on both the transmit and the antenna side till you get a perfect match. Now, in this situation here, I've actually just matched that. That's a beautiful match. You can see there the power is coming up. If we take a look at the barb watt, you can see putting out 3.2 watts with an SWR of 1.05, so almost a bang on perfect match. Now, if I adjust the tune here, you can see the SWR coming up, and there is a sweet spot sitting right down there at the bottom. So it's a matter of adjusting both of those capacitors once you set the inductance in the right zone. See, if I bring the inductance up here, it changes as well. So it's a matter of balancing out all of the inductance and the 2 capacitances until you achieve that perfect match. Now, clearly, this is a little bit big to take with us out into the field, so introducing the Cowtown Buildathon project number 3, which is going to be this little fellow. It's a QRP antenna matching unit. It does exactly the same job that the larger unit does here. You have a central switched inductor in which you select the amount of inductance you wish to use. Then you have 2 capacitors to be able to tune and optimize the characteristics to get the perfect match on your antenna. Now, I'll just make a couple of changes here, and we'll set this up, and I'll show you how this works. So the setup that we're going to use for the next section is shown in this particular chart here. Now, what I've done in this case is I've replaced the little unit that was just passing from straight through out to the antenna with the QRP ATU unit. Now, the unit connects from here back through into to be able to watch and use the SWR meter here, back through into the barber watt to get a far more accurate reading, through into the ADX sitting over here. And as I'll just put it into band mode, you can see here I'm currently on the 40 meter band. Let's just lock that in, and we're 40 meters on FT8. So at this point in time, we switch to bypass over here. So what we're reading at the moment is the raw antenna coming in here on 40 meters. When I key down, you can see here quite unusable, over 8 SWR. The needle crosses right across to the left-hand side there, so unusable in that particular situation. Now let's put the ATU into play. And the first thing I do is I look to the chart up here. I'm on 40 meters, so it's recommending that the starting point is to switch in the amount of inductance which is available when you go to the E position on the inductor switch. I'll also switch it to tune, and I'll just illustrate it. I'll just move it off because I've just tuned it. So when I power down, you can see the red SWR light comes on, indicating that I have an SWR which is too high. I then adjust the indicator here, the capacitance, and you can see there that the light, the SWR light, this little LED here, extinguishes, indicating that that's the best possible SWR. And you can see here that there's virtually no reading. Let me just come and zoom in on that. You can see here when I key down, there's virtually no movement whatsoever in the SWR switch, and the SWR meter. And when I look at the barber watt, you can see here I'm putting up 2.9 watts with an SWR of 1.03. So having tuned the antenna, let's just zoom out a little bit here. Having tuned the antenna, I now just switch to operate mode, and we're good to go. Now the SWR's jumped up a little bit here because we're actually measuring a whole stack of other things that are in there. Whereas previously with the measurement here is actually at this point, not all the way back through the wiring to this particular location here. But effectively, we can now let me just zoom in again with the meter set here. You can see, I'll just quickly go through that again. Put it into tune for minimum SWR, which is just located there. Also, very fine adjustment that we have there, and there we have a virtual perfect match, and we're now able to use that antenna on 40 meters. I just wanted to show another example using the 30 meter band. You can see here that the ADX is tuned to 30 meters. Just lock that in, and we're on 30 meters on FT8. And because the 30 meter band is not an integer multiplier of the resonant frequency that the antenna is cut for, because this is cut for 20 and 15 meters. So we go through exactly the same situation. You can see on bypass here, both units are on bypass. When I key down, we have an SWR which is almost at 7. Across here 7, and you can see that the reflection needle comes right up here. The intersection point is well and truly into the unusable range. So now let's switch across to the ATU. I'll just tune off a little bit here, and I've indicated that we're on 30 meters, so that's the starting point should be around the 10 megahertz, which is selection switch position D on the inductor. Let's put it into tune. You can see the LED comes on. Let me just zoom in on that. Let's get a closer look at that as we do the tuning. Put it in on tune, and I'm coming around looking for that dip. There's the dip there, and you can see that the SWR has dropped down to almost 1 to nothing. 1 point, looking over here, 1.07, and you can see the reflected. Get the reflection needle up over on the. There we go, in focus. The reflected needle power meter is actually hardly moving at all. So we have a perfect match for operation on 30 meters, and so we're now able to use that antenna on 30 meters. Now, there was a lot of equipment used during those demonstrations, but in practical terms, you simply need to connect the ATU to your radio transmitter and use the LED SWR indicator as the indication as to when you successfully tuned your non-resonant antenna. So let's recap. The ATU that we're going to build is a practical addition and complements projects 1 and 2 extremely well. It provides a high frequency antenna tuning unit capable of supporting the QRP radios up to about 10 watts maximum. It's pocket-sized, it's fit for purpose, and it really does work quite well. It utilises a T-matching network which consists of the switched inductor and 2 variable capacitors. The built-in SWR indicator works well, as you've seen in the demonstration, to indicate the point at which the antenna is tuned. Now, the Cowtown kit incorporates an antenna tuning unit bypass switch, the templates to correctly facilitate the drilling and placement of components, as well as the overlay. I'll be producing a detailed construction manual in very similar to the style that we use for the ADX, and it also corrects all the errors with the original Chinese kit. Now, Carol, KP4MD, did an excellent video on small QRP antenna tuning units. She spoke specifically about this particular unit, the problems with it, and the things that you needed to do to correct it. I encourage you to take a look at that video, and we've incorporated all those corrections into the Cowtown build. As with all things, the project is built in stages. We start off by building the small circuit board, which is the SWR indicator and the operate or tune switch. We then build the multi-tapped inductor and then attach that inductor to the selector switch. We drill holes in the case. We then mount the components in the case before moving on, attaching the decal and making the unit complete. Perhaps the most challenging aspect of the build is constructing the 12-tap inductor and attaching that to the switch. But for those that have been involved in the earlier projects, if you can build a low-pass filter and wind your toroid, it's just a matter of patience whilst you build it. But in the end, you end up with a very nice little unit. It's very practical and it works well. So what about the logistics? The kits are going to cost $15, and all proceeds from the sale of those kits will go to the Cowtown Radio Club's Education Fund. Detailed construction manual will be available. All the components required for the kit will be provided, including a bypass switch, which is not in the original Chinese kit. There'll be a replacement magnetic wire because the wire that's supplied with the kit is fairly difficult to work, and we've got some better wire to enable that to occur. You'll also get the front decal or the overlay and an accurate drilling template to enable you to accurately position the components in the ABS enclosure. Now, the club is going to supply 20 kits to its members for $15 each on a first-come, first-served basis. And if you want to grab one of those kits, please email me. The details are shown here at cowtownadx@gmail.com. I'll put your name on the list and ensure that one of them is reserved for yourself. No need to make payment or deposit up front. We'll collect the money for the kits at the presentation night, which will be the third Thursday in October, October the 19th at the clubhouse at 7 p.m. And then a supported build session will be held on the following Saturday for those who need some support and assistance building the project. Well, I hope you've enjoyed the presentation. I look forward to you joining us on the build. It is another exciting project on the journey. Look forward to seeing you 73s.